How's it going, everybody? Eulier Gonzalez here, and in today's video we're going to take a look at the hard part of object-oriented in JavaScript. This is a course taught by Will Sentence, the CEO of Codesmith, which is a software engineering machine learning residency headquarters on London, New York, and California, where he also is showing this content on this academy called Front-End Master, where the goal of this course is to look at how this object-oriented programming pattern is enormously important for writing programs at scale in a professional environment or in a professional engineering environment. So you might wonder why this is important, especially building or writing code at scale. That's one of them. And second is that in a professional manner, because especially one of the things that the economy and business has shown that promote growth and now allow us to have a lot of these devices. So for example, your mobile device, laptop, the internet, food, is that it's important to produce at scale to satisfy more demands on the markets. And with that, growth now allows other peoples to actually promote their own growth as well as in their own communities. And doing that in a professional way, as a way to have this work ethic. The word professional comes from Old French, according to etymology.org, etymology dictionary, which means is profession, which back then it means vows taken upon entering a religion's order. In this case, is vows, but this is based on a commitment and a work ethic and things that you say, okay, this is the activities that I want to dedicate, and I also want to others who are in the field as well as show the same work ethic, and why this is important, because as you do that, you're going to build a reputation that other people will look at that and say, this is the person that we need to. This is the Gaul or Paul that we need to. So with that, the specific objective here is to see, hey, how can we now look at the different styles of OOP, as well as how OOP plays in JavaScript, understand is subclassing, how the prototype works behind the scenes. Now these new features like new class, extends, and inherit works, and how you can improve your technical communications to be precise with others. Part of the thing that this Codesmith business model is all about is that they take some of these people that are from those bootcamp and accelerate their growth to be or for senior roles. And we look at now the code section here, or the core sections, where we see what is the object-oriented paradigm, how can we start creating objects, what are the challenges of creating objects, why do we need a better way, why do we need a better way when it comes to creating objects, and especially when it comes to be memory efficient and pass down or share property and methods with something called the prototype, how the prototype works behind the scenes, how can we make the object creation much more straightforward with the new keyword. Understand now what are the challenges with this approach when it comes to the scope and this, and then underneath the hood, understand is the default prototype change, how can we subclassing or how can we abstract then is functionalities uh, and share that across other objects. So subclassing with factory functions, subclassing with new and call, and subclassing now with class, extend, and super. Something that, especially as you dedicate, or especially in the computer science, is something very, very important. Uh, so here we look at this capability that software engineer actually needs to, whether they are in any particular stage, junior, mid-level, because not only your analytical skills is quite important, based on something. So giving a task, how do you do that task even though that you haven't seen that problem before? Find a way to pushing through the blocks. And something that a lot of companies are looking for, and this is also great for yourself, is that how is your ability to express those complex topics and make it meaningful to others, empowering a team. So can I implement your approach based on your explanation? That's all about. And then we talk about is how are the best practices that software engineers must follow, soft skills of being empathetic, having patience, and ultimately is the language skills and technology and that kind of thing. All right. So with that, okay, first we'll look at the object-oriented programming, which is, it all starts at the 60 as a way to understand or find a way of how can we organize data and its functionality and bundling together. So objects came around, okay, and this paradigm now we look at how OOP plays in JavaScript by looking at the object creation. What are the several ways of how can we create objects, whether it's object literal or object dot notation by adding property as it is, or the object dot create, which now this give us much more control about which object can have access to, which is something underneath the hood, is creating the link necessary for sharing those functionality, as well as the object creation with a function. And what is the challenge involved that? So because after all, especially when you are creating objects inside of a function and with that object dot assign, so for example, like this, okay, yeah, for example, like this, or in this particular case, like this, all right? Wait a single moment. Like this, okay, and I didn't put that one. Okay. So yeah, because we are looking is that now how can we create functions? Jesus, what it is this one, okay? Because we are looking at how can we create objects with a function like this. The problem with this approach is that anytime we are creating is a new function, we also are duplicating that functionality for every object that we have, which is not being memory efficient. And imagine that you have 100, 200, 500 users and they say, oh, all right, that's not working, that's not feasible. So how can we fix this challenge here? So how can we extract now the functionality, okay? And anytime we create is an object, we point to that functionality. We have a reference to that. We don't create a new copy from that. So that's what we use, for example, is something called the object.create, okay? So in this case, we define is the functionality in an object, here. Okay, we define all of the functionality in an object, and when we run the functions to create our objects inside of that, thanks to the object.create, it will create this link for us based on the object that we passed to say, hey, this new user, this empty object that we're going to create, all right, I want you to, because this is something that happened behind the scenes by default, you're going not only to create is the objects, all right, but also you're going to point the objects to whatever function or whatever functionality this object has. In other words, you're going to now, thanks to the product, okay, thanks to the product, what you're going to link is to the methods and functions defined inside of that object. Okay, so that's great. That's good. This is the sophisticated. Some people call that the sophisticated way of creating objects. This is something that you're not going to find in production or in any professional environment. But the point of this is that it illustrates now one of the reasons of how OOP plays in JavaScript. Okay, unlike other language where you don't need to do this, you just only say, hey, okay, this is the data, this is the functionality, all right? So here it is. That's all. But in the case of JavaScript, based on how it was designed, and it has now this particular mechanism of sharing functionality in a memory efficient way with the prototype. That's what we have to do this. Okay, so right now the question with this is that even though that is a straightforward, once you know that, it's quite verbose, and also it's a lot of handcrafting thing that we're doing. Why is that? Because anytime you want to create a new object, and especially object that has or share common functionality from one or multiple objects, it can become quite tedious and quite monotonous. So is there any alternative and any better way to do this? The JavaScript designers come up with this thing called new, where the idea there is that let's go to automate that particular process of the object of creating of the object creations, but there's some trade-off and some drawback associated with. So what this means is that the way how the prototype walkthrough, which is the way how now anytime you create a new objects with object.create or with an object itself, okay, the prototype means, based on the specification, that share property to other objects. So anytime we create an object by spec, we add some hidden property that in the spec described as property name, which is here, for example, prototype, which is something that browser implementation set as proto, which is a bad name for to refer. That's one of the things that is quite complex here. But after all, this proto just whole is a reference to the functions prototype, or the object that you pass and their prototype, where the prototype holds is all of these implementations. So you want to take a look at this. You see, hey, if you don't lose your mind, I'm going to do this by itself. Which is, let me actually create this new object here. We say const new user one, user one, then we say, hey, this is a new object literal, we contain his name. Okay, so name, we say, hey, Arthur, comma, Arthur, that's one of them. The other is, yeah, just name, just name. Let's also add that, this last, age, 19, okay. Let me, what, unexpected line break, what is that? Okay, no, what's wrong with you? Oh, really? I get it. There you got it. Okay, let me also define as another object here, comes new user2 with the thing here as name Charles, and the age of 21. Okay. Oh my god. Missing after property ID, name, and Charles. Oh, okay. There you got it. Exactly. Okay, so if we take now at the new user here, and we say, hey, this proto, what is the value that you're pointing at? This is actually pointing to the object reference. So far, so good. And this object reference is containing all of these property and methods from the objects. So in other words, the new user one, if you want to take a look now at their own property, you have now several methods that is exposed to, like has own property, is property of, and when you talk about is prototype of, it means that this object belongs to this, has this instance. Name, property is enumerable to local string and that kind of thing. And here that you can see, we can actually access to the proper value there. So you can also ask a question here and say, hey, has own property of name. It's a way to check that. The whole point of this is that when you are creating your object, this is what it's doing behind the scenes. And when you want to call is a method that exists, for example, here on the increment, okay? We're gonna now take a look at how can we call this thing here. All right. So if we actually do something like this, okay, and then we say, hey, let me create is now a user one, create user creator, exactly, user creator. We're gonna pass is a name like Phil, and the score is 4. Once you want to access to the prototype, for example, to say, hey, the increment function exists, what it's doing behind the scenes is to look at the own properties of that object, if that exists. If it's not, then let me take a look at the proto. Okay, let me take a look at the proto here. Proto, the underscore proto, underscore. Okay, to see if in there we have one of these methods. And in fact, we have them, to see if in the prototype it has this, right? Like so. So this is the way how can we now access to this prototype change, because this is a way how you can share property and methods. Again, because that's a lengthy, long process for any time you create an object, okay, and share common property and methods. The thing with the use of new keyword is that, well, it not only automates that process, and also remember that at the end of the day, when we care about on the object-oriented programming is that how can we bundle the relevant data and it is associated functionality together, okay? That's the entire reason of looking at this. And yeah. All right. Yep. Okay. So you may wonder, okay, how can we now, in our case, take a look at that? Because if you can imagine the nature of the proto, which is a hidden property that is created when you create an object, is just the ability to have a link to that object that contains all of this data and property that we can have access to. And we can share that functionality and data across different objects. So the point of this is that, okay, so far so good. This is actually quite interesting way to do that. It's quite repetitive, it's quite verbose. It's actually not great when it comes to it doesn't improve readability. Is there any better way? So after we look at what the prototype, how the prototype works, the prototype walkthrough, to see what's going on there, and to understand, after all, what is the end goal of the object-oriented programming, okay? We now take this particular approach with the new keyword, where instead of you manually create this reference, let the language create that reference for you. And there's some things that you need to abstract or you need to do in order to work with this new feature, which is the new keyword. So, new keyword is a way of how can we now automate the process of sharing properties and methods in a memory efficient way. So we don't have to manually create their link using the object.create every time we create an object. That's the value proposition of the new keyword. Okay, let me in fact actually wrote that here, right? So the value proposition of new keyword, okay, so the value proposition of new keyword is we don't let's the language create, or let's the language automatically create, or yeah, let's the language automatically create the reference. Yeah, let's the language create, let's the language lets the language automatically create the reference. Exactly. So let the language create, let the language automatically creates the link or the reference that allows to share. Let the language automatically create the sharing mechanism. Okay, so let the language automatically create the sharing mechanism of property and methods. Okay, so let the language automatically create and let the language automatically create and create. Let the language automatically create an object. Let the language automatically create an object and the sharing mechanism properties and methods in a memory efficient way. In a memory efficient way. Okay. Yeah. So let's the language automatically create an object and the sharing mechanism of property and methods in a memory efficient way for us, instead of doing that creation and link in sharing mechanism manually with object.create. Okay, so that's the value proposition of the new keyword. The question is that, fine, now you know what it's doing, I want to know how it works, and that's when things getting quite interesting. So here we need to do a couple things. Okay, so we don't need to use the object.create and we don't need to return the object automatically. So because now we don't need to actually create our object.create here. Okay, we need to find a ways how can we access to these objects using this keyword. Okay, so far so good, but again, a problem remains, and the problem is that the mechanism. How now is this new keyword creating is the linking mechanism? So for that, first we need to create is the object with the data, and then with this hidden property as a function. There's something important here. So okay, I think this is something that is going to make sense. So far so good. We look at the object creation, how you can do that with object literal, object dot notation, which is not recommended to go to do that, as well as with object.create and object creation with functions. And what is the challenge with that? Okay, so the challenge is that it is handcrafted and you have to do that every single time you create an object. Okay, so far so good, no problem. The thing is that, is there any better way to do that? So for that, the JavaScript language come out with a particular keyword that will automate the creation of a process or the creation of an object, as well as the sharing mechanism of property and methods. So you don't have to do that manually using the object.create. And there's some ways, and there is a particular way of how you can do this. First, you need to define is a function. So these functions, where you're gonna only hold is data, okay, the property of this, And inside of this function, this is a hidden property called prototype that is created anytime you run a function. And this is something important because after all, functions are objects, are a special type of objects. It is this combo object function, okay, where you have now this hidden property called prototype, where you're gonna hold all of these property and methods that you wants to define inside of that. So why do we have this little store? As a way to this function act as an object. So now that we know how this function object work, okay, which is also a special type of objects, which is a callable object, okay. So unlike normal objects, you just only is access to the property or methods, okay. But now with this function object combo, you can also call that. So functions have the hidden property called prototype, where this is when you hear terms like, hey, put in the prototype, put in the prototype, put in the prototype. That's what it means to, is putting all of these specifications or these data methods there. So this is an store of that. Good. So once we know that, okay, so especially when you're going to create a new object with new keyword, you're going to define as a function with all of the data there, and then you're going to access to the prototype, what you're going to define is the properties or methods, particularly methods, that you want that this object function has. So when you're going to now run this functions constructor or functions object creator, okay, you use a new keyword and it is going to do something in the background. First, it's going to set the this to this object pointed to this new object created, where you can add now property and method to these objects. Behind the scenes, when you're creating these objects, on where you can point, where you can have access using the this keyword, it will set is the proto underscore the dunder proto dunder. It will hold is a reference to the prototype for whatever object it has been created, where now the prototype it contains all of the property and methods from that object, okay, and then you're going to return the objects. That's one of the reasons why we have things like this, a function here, or as the function constructor, okay. So this approach is something that is quite feasible, quite understandable, all right. So for example, if we now take a look at this, which is one of the things that this new keyword is actually doing behind the scenes, and if you want to evaluate step by step this, so for example, hey, let's go to actually describe what's going on here. So we are creating is a function called user creator with the parameter name and score, okay. So we are now holding that in memory, and then we're now adding a property, or adding a property called increment to the prototype, and let's go to assign that a function, okay. Where in this case, this is how can we access now to this value here. Remember that the value this in JavaScript is contextual, is whatever is on the left side when the object is called. So it means that it's dynamic. Similar to this. So with this approach, which is something that you are going to see in a lot of professional code base, this is how you can actually remember. Bundled together is data and relevant functionality together. So that's great, okay? And with the use of with the new keyword, that's what it's gonna do. It's gonna set the value of this to an empty object, okay, where you can now add all of the data needed to this object. It also goes to create is the link, the prototype change by anytime you create an object, you have a hidden property on the browser. You have a hidden property called the dunder, which is underscore proto underscore. That double underscore is called the dunder. That will point is to now the functions construction or the prototype of that function we create. That will contain is, well, all of the property method that we define inside of that. And then create a new object and return that. So the problem with this particular approach is because, which is something that we're going to see that, that's why we need is to take a look because I really see what's the problem with this approach, okay, is that when you want to, for example, extend functionality inside of that other functionality, because the value of this is not fixed, it depends on where this is being called. That's where new challenge came here, and that's where we're gonna take a look at in today's video with the scope, right? With the scope and this. There you got it. Scope and this, yes. Scope and this.
So we are calling user.
So right now we're gonna take notes out of the will sentence course. So that's great. Cool.
Model increment. Elliot, talk me through the lookup process of this increment function, and let's see what actually happens. Talk me through the lookup process, Elliot.
We look in global memory for user one.
You find it,
And then we look for increment.
Let's just walk through this code here, and let's walk through our call of the increment method. Let's see it actually play out. So we are calling user model increment. Elliot, talk me.
Exactly. Slide. Screenshot is me. Screenshot. So in this case is calling prototype methods, exactly. So calling prototype methods. There you got it. Things like this. Let's go open this. Calling prototype methods. Let's see. Okay, where is the image? Where is the Kraken? Okay, so now that makes a tons of sense. Come on, there you got it. Yes, sir. Calling prototype methods. Let's go to walk. Let's go to walk through this code. Let's walk through this code, okay? So for example, here. So here we're defining is a function called user creator that takes name and score as parameter.
Talk me through the lookup process of this increment function, and let's see what actually happens. Talk me through the lookup process, Elliot.
We look in global memory for user one.
You find user model increment. Elliot, talk me through the lookup process of this increment function, and let's walk through our call of the increment method. Let's see it actually play out. So we are calling user1.increment. Elliot, talk me through the lookup process of this increment function, and let's see what actually happens. Talk me through the lookup process, Elliot.
We look.
And based on the following diagram, okay. Okay, so let's walk through the user. Let's walk through the user1.increment process. Okay, the process. So process. Okay, let's walk through the user increment process. Yeah, let's walk through the user1.increment process here, following our diagram. Okay, so following our diagram here, take a look at, oh come on man, enough. Download, not because it's on desktop. Okay, so the process here is that it's going to call increment. Okay, first you're going to take a look at this object. Do we have that in memory? Yes. Do we have that? All right. Do we have that in the object itself, the property here? No, we don't have them. So let me now take a look at the proto, okay, which holds is a reference to the prototype function here. Okay, again, remember, because at the end of the day, this is the way how you can create is object with the new keyword. So this is a series of steps that we need to do as a way to automate the process of as a way to automate the sharing mechanism property, as a way to automate the process, as a way to automate the sharing mechanism of property and methods. Okay, so take a look at that. All right, this increment function, yes, this is a function, and let me call it. So once you call that increment function, it creates a new branch execution context, and the question is that the value of this, let me actually put it this. Let me actually write it here. So exactly. So let's walk through the user1 increment process. So first, exactly. So first, yeah, there you got it. So first, so first, exactly. So first, okay. So first, we are going to take the we're going to pick at the user1 object if on memory, if we have such method. Okay, which is in this case increment. Which is in this case increment. Okay, so far so good. So okay, increment. In memory, if we have such a method, increment. So because so JavaScript is going to look, that's right, because it's JavaScript that you're telling to do this. So JavaScript is going to look at user one objects in memory if we have such a method called increment. Okay, because we don't have that. Now JavaScript is going to look. So now JavaScript is going to look at the proto. Okay, so now JavaScript is going to look at the proto here, which, that's right, so which contain, okay, exactly, because we don't have that. Now JavaScript is going to look at proto, which contain which contains a reference to the prototype, okay, to the prototype property that contains a reference to the function prototype property, exactly, which contains a reference to the function's property, prototype property, okay, to look, and then contain a property, then look up for increment, there, if it's there, since we got this, now it will run our function, aka it will create a brand new execution context. So the value of this, what will be? You know, so the value of this, what will be? Okay, whatever is anything that it's on the left side when, exactly, anything that is on the left side when the function is called. Locally is, so locally is our user one. That's where we can have access to the property and methods, in this case the score, and increment that, okay, while updating the data only for that user. So that's great, you know. So that focuses. So while only updating the data from updating the data of user one. Yeah, that's right. So we're only updating the data of user one. And that's pretty interesting and powerful, because these functions that can be across in a memory efficient way to any other objects, to any other data that are unique, okay, we can now keep track on memory which state do we have of all of the data. That's pretty powerful.
Look in global memory for user one.
We find it.
Find it, and then we look for increment.
Do we find it?
No, we don't find it.
We do not. Do we panic?
Nope.
We do not. JavaScript looks on the
Proto,
and it finds a link up to
the prototype object.
object on the user creator.
Exactly. Object on the user creator, exactly, which is something important here, which contains a reference to the function prototype, which contains a reference to the function prototype object creator. Okay. Come on, man. Object creator, exactly, because it contains a reference to the function's prototype object creator. Then it look at the increment. Do we have that? Yes. All right. Now it is time to run these functions. The parentheses indicate that, and then it will create a new branch execution context with the thread of execution in local memory, and the value of this locally in your case is whatever is on the left side when that function was called, which means is context dependent, it's variable, it's not fixed. In your case, it's user one, so that makes sense. So far, so good. So far, so good.
Yep.
By the way.
And there we find
Increment.
increment. Let's not just say success. We found the function. We can call it. Let's actually now execute that code, and let's see what happens. We're calling the function increment. Let's create everybody a new. That's part of it. A new execution context. Let's create that execution context. There it is. What's the line of code inside of it? Seth, what is the line of code? Just literally give me the line of code. This dot score plus plus. Fantastic.
Okay.
Folk. Oh, they've got a posh name for the this here. It's called an implicit parameter. Ah, I learned that name recently. Look, this increment function now, we don't have a unique copy of it designed just for user one. Nor do we have a unique copy of it designed just for user two. Let's actually just quickly create a user two so we can really explicitly see this. There's a user two with, I don't know, let's say name Jeff, score 8, and it too has a proto bond up to. So both user 2 and, what's it says user 20 actually, both user 20 and user 1 are going to be using the same increment function. So how are we going to make sure that it explicitly targets user 1? Because if I wrote the code in here instead to say user 1
Exactly.
dot score plus plus, such that I would go to user 1, increment its score, well now I'm using that same function on user 20, all I'm ever going to do is increase user 1's score. So I've got to make my function general enough that it can work on any of these objects. Now normally when I want to make something general, I use a parameter, such that when I call multiply by 2, it's not multiply 3 by 2, the function, it's multiply something by 2, and when I call the function, I determine what that thing is. And I replace the placeholder, let's say num, with 4 or 3 or whatever. Well, we've got a problem here, that this function similarly needs to be, when it's called, applied to a particular object, the one that's pertinent at this moment. What placeholder, what, they call it actually, I discovered, implicit parameter. It's implicit, it's one we don't explicitly state, but it's put in there for us. What implicit parameter, what placeholder does JavaScript give us, Terry, that allows us to refer to the pertinent object at hand?
This.
And it is a total.
Updating the data of user one. Thanks to the value of this. Or the mechanism.
Placeholder does JavaScript, I discovered, implicit parameter. It's implicit, it's one we don't explicitly state, but it's put in there for us. What implicit parameter, what placeholder does JavaScript give us, Terry, that allows us to refer to the pertinent object at hand?
Thanks to the value of this, which allow us to access the proper data that we want, so that we need. I think to allow to access exactly. 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 Right. So
this. And it is a totally different this to the one we had when we created the object. When the object was auto-created, it got the label this, and then the object was returned out to user one, and that this, because this execution context was deleted, the this was definitely lost. But the object was returned out. The this here is a totally different this. And there is one simple rule for its use. Whenever I call a method is a function on an object, it always, when I create the execution context, immediately in the local memory there is a this assignment. In fact, there's a this assignment, this declaration with a value the whole time in JavaScript. Any execution context has a this. The global execution context has one. And the this there refers to that global window.
the global window.
Regular functions, not called with new or called to the right-hand side of a dot, they also have a this inside of it, but it's pretty useless. It always refers to that weird global object thing. It's pretty useless. But there is a profound use when I'm trying to call a function, when I'm trying to write a function like increment that will refer to the right object at the right moment.
Exactly. So the value of this is something. Yeah. So the value of this is something that is created in every execution context. Okay, in every execution context. So in the global execution, in the global, it points to the window. Okay, it points to the window in the browser. Okay, in the browser. But in functions is quite useless. Unless it give us the proper data that we need when we call a function on it. And that's something part of the key of the value and the reason to understand now
And there is one
the
simple
this key.
When I call a method, a function, to the right-hand side of a dot, it will automatically, as soon as that function gets called, its execution context opens, the this will point to the object to the left-hand side of the dot. So Nick, what, when we call increment, will the this immediately be assigned to? What's the left-hand side of the dot? Of the dot.
User
so
one.
Nick 1 to user 1. And so, David, when we run increment on user 1, there was no increment function on user 1 itself. It was in this set of shared functions. We want to make sure it can work on user 1 and user 20. Well, we're running it on user 1. What does the this.score++ evaluate to?
It is evaluating is the user 1.
User one's score.
Fantastic. User 1.score++. Let's do our lookup journey. We look for user 1 in local memory. It ain't there.
No.
We look out to there it is, and we increment it. But what if it had been on user 20 dot increment? Let's do that journey. Let's make sure we're really, really clear on this. I know it's a bit repetitive, but let's make sure we're really clear on this. Nick, user 20 dot increment. We look up.
User 20 dot increment will look to see if increment is in
To
the
see increments in the
If it's not,
product.
Fantastic. Dot increment.
Exactly.
We look up.
So
User
so
20.
again, this is another example here. With user 20 with lookup, if we have that increment property on our object, we
dot
don't
increment
have that.
will look
We'll
to
take a
see
look
if
at the
increment is in this
proto.
object, and it's not.
Fantastic.
It then doesn't give up and goes to proto.
Fantastic.
Exactly. And then it doesn't give up. That's part of the JavaScript. And then it doesn't give up to the proto.
Then
Well, yeah, goes to proto, sorry, which takes us to user creator.
creator.
Exactly. Then it doesn't give up, and then you take a look at the proto, which holds a reference to the prototype, to the prototype property of our function object creator.
It finds increment there.
We grab its code.
and grab
So
that.
we grab
Create.
that, and then you get it.
Fantastic. And into it we go. What's the immediate
Then we
thing
execute the code.
that's assigned in local memory?
This.
This, which is automatically assigned to whatever is to the left-hand side of the dot on which that execution context is being called. So Nick, what is this?
This is user 20.
User 20, fantastic, man. Well, look at that. This is very helpful. Now we've got a this.score++ that's going to actually have a meaning. And so our this.score++ is going to evaluate to, Nick,
User 20 dot score.
Fantastic. We look for user 20 locally. It's not there.
It's
We
not
look
there.
deployable, it's there, and we increment it. Beautiful. Okay. This is a different use of the keyword this to that use of the keyword this. They are totally unrelated. Totally unrelated. One is the auto assignment of this, which in other languages that's not a crazy thing because these things are closer. But in JavaScript, I really wish they'd called, I don't know, I really wish they'd given them different labels. One is like, call this one auto-created object.
Isn't that so?
Yeah, I just wish it said, so you could then go auto-created object.name equals name. How much more clear would that be? Rather than this. What the hell does this mean? I always feel like language designers get really familiar with things that become almost intuitive to them. And therefore, they design their new language as though this is a relevant, is a sensible name for an auto-created object. No, call it auto-created object. And call this one the object at hand. The object at hand dot score plus plus. My languages would be very verbose if I created a language. It would be very long. The object at hand. The
Okay. So language creators, or language designers, especially in JavaScript, make the value of this quite weird and annoying to predict. Because it's also not that meaningful, not that meaningful.
object at hand dot score plus plus. My languages would be very verbose.
Yeah, me too. Yeah, me too. If I'm going to create a language, I'm going to do that the same. So language designers, especially, exactly. So language designers, especially in JavaScript, make the value of this quite weird and annoying to predict, because it is also not that meaningful as a concept. What in the French toast is the value of this? You know?
I created a language. It's a very long form language. All right, so let's do this again. This time the only thing that's changed is our increment function now has a little function declared inside of it where the this.score++ is being being stored, and then we're going to run that. Now, in reality, we're never going to store and add one function that does one line of code and then call it. We're just going to do it directly. But I'm doing this because I want to reveal something that is probably the biggest gotcha in object-oriented programming. This is the biggest gotcha in OOP, okay? And I gave this talk a few days ago and asked someone who'd been interviewing recently. This question came up in their interview. It is a favorite gotcha bug in OOP.
Mm-hmm. So this is a favorite gotcha bug in an interview. Yeah, of course. Of course.
We're going to understand how to solve it and also why it happens.
So we are going to know.
So let's do this again. We've had Nick and Chris walk through this. We're going to do it one more time. Here we go.
How
so,
to solve it.
No code has changed, people, except for the
why
body
it
of the increment
happened.
function. Don't get confused here. Everything's the same except for the body of the increment function. So let's go back to our final line of code.
This keyword scoping.
Increment. User1 dot increment. Seth, talk me through the process.
It's going to attempt to look for increment on user
Keyword.
1. It's not going to find it. It's going to freak out a little bit. But then it's going to say everything's okay. I found the prototype.
Exactly.
You're gonna freak out a little
Through
bit.
the process.
It's going to attempt to look for
You're going to attempt to log. Yeah.
increment on user 1. It's not
Okay.
going to find it. It's going to freak out a little bit. But then it's going to say everything's okay. I found the prototype.
Exactly. Oh, so you saw there that Seth called it, I found it on the prototype. People
No. So it's not about, is that it's going to find that on the function object creator prototype property.
do colloquially say, look to the prototype. Do you see why I don't like that? When it's referenced in the underscore proto underscore that happens to be linking to an object that happens to be called prototype. But we could redesign the new keyword to say, make it link, call this instead, I don't know, function store. and have the new keyword be redesigned to reference user-created.function store. Prototype is not a magic word.
Exactly.
Proto is a more powerful word in my view.
Because it contains the reference.
Like that's an JavaScript automatically looks at proto when it doesn't find.
Mm-hmm. So the key process.
And then it goes to this object which happens to have the name prototype, because that's where the bond was made. But we could overwrite that. Oh, in fact, we could literally overwrite that. We could say, we could manually later go user creator dot function store equals this object full of functions, and then we could put in here user1 dot underscore proto underscore, or we can use set prototype of. We'll see that later, and put a different object of functions in here. There is nothing profound about prototype. It just happens to be the auto-designated place that, with a new keyword, the link is made to. Okay, little aside there. But there we go. We find increment, and we create an execution context in which to run it. And try and make it a little bit bigger. Okay, there it is. And in its local memory, Seth, what is the first assignment that automatically happens? There's no argument parameters. There is an implicit parameter, is there no?
This becomes user1.
This becomes user1. Fantastic.
We declare a new function called add1.
Fantastic. Yeah, add one, store it, and then we immediately call it. So give me a second. So add one.
Exactly. And then we
It creates a
immediately
new
execution context.
Fantastic, Seth. Into it we go.
This gets assigned to.
And
Okay,
this is
excellent.
assigned
So-
to. This gets assigned
What does
to
this get assigned to here?
whatever is being called on the left side when that is happened. In this case, it'll be fucking window.
Michael?
Window.
The function is add1, so it's an anonymous function. It's an increment.
No, it's not for window.
So lots of nice suggestions.
Window.
Susie?
Window.
Yeah, absolutely. Who knows? Because I told you one simple rule. That this is assigned to the object to the left-hand side of the dot. I don't see any object to the left-hand side of the dot here. So what does it
Exactly.
default to?
The
As
window.
David says. All the way to this random ass window object thing. So there it is. This is assigned to window, whatever that is. I still don't quite know. It's just an object with all the features of JavaScript in. So let's see what our this dot score plus plus is.
And then he's going to
It's actually
see.
going to say window dot score
The
plus
score
plus. We're going
plus
to end
plus.
up with, on our funny old window object thing, a property called score. It's probably not a number, because it should be undefined, right? And then you try and add 1 to it, you get NaN. This is hopeless. And yet, in object-oriented programming, having sub-methods, I don't know what you call them, but like a method, sub-functions within a method is absolutely appropriate. Because, you know, this increment method has only got one line, but often you've got
Exactly.
50, 100 lines. You want to organize that into sub-functions. But if you do, and refer to the this, unlike any sane language, actually I love JavaScript, but this in traditional languages would look at this and frown, the this does not point to the object, which is obviously the pertinent object. But it's by design.
Exactly.
The this is only assigned to the object to the left of the dot. There ain't no left of the dot here.
Exactly.
So, there were old ways of solving this, which some of you may be familiar with. People used to say, okay, well, here,
Let me actually apply something. Let me actually pass it out as a reference, as a self, and applying
that
that.
equals this. And then that would point to the user1 object, and in here we refer not to this dot score plus plus, but that dot score plus plus. Does anybody think that's a good design decision? Apparently it's quite efficient. Apparently it's actually quite
I mean, solve the problem.
quite efficient.
It's a
I don't
bug.
know why. Alternative would be to use bind, call, apply. We'll see those in a moment. But I think now the standard approach is to use, well, who knows, Steph?
Arrow functions.
Add on the prototype, wouldn't you?
Arrow
Anyone know what
function.
the, Tim?
I can't
There's a new way of declaring functions that when they're called, they're this inside of them.
Arrow function.
Arrow functions, exactly. They've recently been rebranded from fat arrow functions just to arrow functions because there was no need for them to be called fat arrow functions, apparently. So before we see those, I want to make really clear, because you'll never see me declare functions this way. I want to make, well, sorry, arrow functions, but you'll never see me declare functions this way. But I want to make really clear that this line here, the blurred out line, add1 is a function. I want to make clear that is an identical, for our purposes, it's a hoisting thing, but ignore that for now. That is an identical function declaration to the one above. See function add1, store the function add1. That next line there says add1 is a label for the function that has the code this.score++. I just want to make sure everyone gets that that is an identical function. So the one is called a function expression, and the one I always use is called a function declaration. But they're identical. I want to make sure everyone gets that that is an identical function. So the one is called a function expression, and the one I always use is called a function declaration.
Oh, okay, because this is this. One of them is functions declaration, and the other is functions expression. In here, that.
But they're identical. Just because in a moment you're going to see an arrow function, which looks a lot like the second one, but I don't want you to think it's some sort of special different function. So let's switch this up. Rather than declaring the function add1 using the traditional function declaration or expression, neither of which give us the right this assignment inside and leaves us doing silly stuff like that equals this, which was really, really standard, people.
Yeah,
Absolutely
yeah.
standard and very strange. Instead, we get a new way of declaring the add1 function such that when it's called, this assignment is automatically what's called static or lexically scoped. That means it's
Exactly. Exact lexical scope, which is we want is now more deterministic behavior. We want more certainty here.
going to automatically refer to the this from where it was born. If any
For where it was written.
of you seen closure hard parts, you know how important where I save my function is in JavaScript. Well, with these arrow functions, it's super important. This from where it was born. If any of you seen closure hard parts, you know how important where I save my function is in JavaScript.
Exactly. When you are using with
Would
closures.
automatically refer to the this from where it was born. If any of you seen closure hard parts, you know how important where I save my function is in JavaScript. Automatically refer to the this from where it was born. If any of you seen closure hard parts, you know how important where I save my function is in JavaScript.
Exactly.
Well, with these arrow functions, refer to the this from where it was born. If any of you seen closure hard parts, you know how important where I save my function is in JavaScript. Well, with these arrow functions, it's super important. Where I call it, the this will be the same as where the function was saved, where it was defined.
Exactly.
And that's going to solve our whole problem. So let's just walk through it, and then we're going to get to solution 4. But this is a nice little interlude I want to give us to say is absolutely appropriate. User 1. That next line there says, add1 is a label, and the one I always use, but I don't want you to declare function
The arrow function.
approach. I think that's a good design decision. Apparently,
So now let's walk through this. Go here. Especially on user increment. As it is, and then with this. So we designed to evaluate is our function here, and especially with the increment. Boop, 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 boop. There we go. Let's now evaluate is the user1 dot increment, okay, when we now want to add new share functionalities, new share functions, okay, share functions, okay. So what happened there? Okay. So in our case is something like this. So this is our diagram. Take a look at the user1.increment. And let's go to describe it. And let's go into describe it. Okay. So what it's doing is that, hey, JavaScript is now take a look at the increment and you say, hey, do we have that in our object? No, we don't have that in memory. Okay. So I don't panic. Okay, chill and take a look at the proto that holds is a reference to the prototype function creator, function object creator. I think this is that have a reference to the functions prototype object creator. And why this is important to describe, because JavaScript, anytime you create a function, is a special type of object that has by default generated is this hidden property called prototype, where you're gonna hold all of this data and methods that you can have access to, pretty much like an object. And if you can define functions, or if you want to run this function, you use the parentheses. So, all right. So because now, once we take a look at the prototype functions object creator, okay, and that specific way of describing is something important here. Uh, then inside of that object, we say, okay, what do we have here? Do we have this thing is called increment? Yes, we do. Yes, we do. And we're going to create now is a brand new execution context because we're actually running that, which is which contain is now inside of that is a functions declarations and then the function execution here, where again we assign this in memory in our new brand execution context, here. So we now have this function called add1. We store that in this local memory, and then we run that. In other words, we run is a new brand execution context with the function, where in our case it say, okay, what is the value of this? So the value of this is whatever is on the left side. In our case, what is the thing that is on the left side? Because there isn't anything there, well, by default the value of this is window. So we are now pointing this to window object, which is quite weird and something that a lot of people on the interview love to ask about this feature bug in JavaScript. Let's walk through this. Let's freaking walk through this, man. Let's freaking walk through this, man. Yeah. Let's freaking walk through this, man. So one, JavaScript, or let's gonna put it here, evaluating, exactly, evaluating JavaScript. Exactly. Evaluating here. Exactly. Evaluating is user one dot increment statement. Okay. No. Okay. So evaluate user one increment statement. Yeah. Evaluate is the user this. So evaluating is the user one created statement. First, if you say, hey, now let me take a look at, so JavaScript is JavaScript is so JavaScript is going to look at user one at increment function or an increment function in the user one object. Doesn't find it. It doesn't exist. Okay, it doesn't exist. Then JavaScript doesn't panic. Yeah, the JavaScript doesn't panic, and go to the underscore the dunder proto dunder, which holds or which points or which holds a reference to the functions, a whole reference to the function prototype object creator. Which is a store where we can put all of this functionality and share that across different objects. So JavaScript, again, look up for increment, and now it finds it. So proceed to execute the function. Proceed to run the function. Exactly. And proceeds to run the function. It creates a new brand execution context, or a function execution context. Okay. That's right. It creates a new brand execution context where it associate the where it evaluate is where it does the following, set the value of this to the user one. Okay, set the value of this to the user one. What's the next one? Store the add function in local memory. Exactly. And then run the add function here. Okay, then run the add function, which creates a new brand execution context. Okay, where it creates a new brand execution context. Here, the value of this is now window. See, here the value of this since there is nothing on the left side, because it is so by default it is the value. Exactly, it is a value that is, so by default it is whatever is assigned to the left side. Since there is nothing on the left side, it points by default to object. Therefore, we are now increment we are now increment we are now running the window dot score plus plus statement. The lesson here is that we are not able to change or we're not able to update the proper data. We are not able to update the proper data, and we're going to see how to do that. And we are going to see how to do that and why that happened. Exactly. We're going to see how to fix that. There are there is a solution. There is a solution that looks like more like a patch by assigning by using that by storing the value by storing is the data value into that variable which is something that is fairly common. That variable into that variable, and then assign that to the this keyword. Assign that to the this. To this keyword.
It's quite efficient. Apparently it's actually quite efficient in terms of performance. I don't know why. It's from where it was born. And then we're going to get solution 4.
And that's what we have, for example, apply and buy. That's the reason why we have apply and bind. To change the value of this, or to make the value of this relevant, to make the value of this relevant when it comes to run a proper function with a valid data. So when it comes to run a proper function with valid data, or the proper function with the proper data, and we're going to see how to do that. That's right. And we're going to see how to do that. But it's all about is data and functionality, and how can we bundle that together.
This is a nice little interlude I want to give us to save us from the biggest gotcha in OOP. That was the biggest gotcha. Calling functions inside of methods and it referring to nothing that we wanted. This being misassigned. So let's call our increment function one more time. I'm going to talk through it so that you don't all have to. Okay, user1.increment. We call it, we look to user1. For the increment method, it's not there, so we look to its proto underscore, which links us up to the object
function prototype, to the object prototype function
the label
creator.
prototype that sits on the object of user creator. That is user creator, the function object combination. We grab the increment function, we create an execution context. In its local memory, we immediately assign the implicit parameter. This. That means implicit because we don't pass it in, the argument to fill it in, but it's always there. There it is, this, and its argument, I guess you could call it its implicit argument, I guess, is whatever is the left-hand side of the dot. User1. Okay? Beautiful. And then we declare a function, add 1. I'm not going to go into exactly how these arrow functions work, but you can sort of see it's got no parameters. It's identical, basically. No parameters, no inputs, but its body says this.score++. Okay, so we declare that arrow function. There it is. I'm going to do a little arrow above. That's how I'm going to direct a special level function. It's an arrow function. But it looks exactly the same as you run it by calling add 1. But it has one powerful difference. The this inside of its execution context is going to refer to whatever the this was when it was defined. I'm almost going to, I'm going to do like this, this is called like a hidden property that says my this later on will be what it was when I was defined. So let's call it now. Add 1, new execution context. Seth, first thing in my local memory of this new execution context.
This is assigned to user 1.
Excellent. The this is assigned to what the this was when this function was defined, when add1 was defined. And remember, when I say add1 was defined, that means literally add1, never lose sight of this. That means add1 was saved as a label in memory for that code, which means you can certainly add hidden stuff to it, including a hidden property. Add1, never lose sight of this. That means add1 was saved as a label in memory for that code, which means you can certainly add hidden stuff to it, including a hidden property saying, when you call me, make sure my this assignment is to whatever the this was when I was saved. Okay? To user 1. And so now, as Seth rightly said, our this.score++ will evaluate to user1.score++ against all the odds. Because look, add1 is not called to the right-hand side of a dot, so how the hell is the this referring to user1? Because it was defined as an arrow function. All right, there it is, user1.score++, no user1 here, no user1 here, user1 is out here. We increment it, its score. Okay, folks. This is our new best practice for how to handle what is a very, very standard procedure of defining functions inside of methods, calling them, needing to refer to the object at hand. We're not running a function inside of here to not refer to the object.
If you need to refer to the object at hand, you use the arrow function for that.
But now we can easily refer to that object. Okay, people. Yeah, let's have thumbs on this. You lost me. I'm clear. I have clarifications. All thumbs up. But yeah, okay, go ahead, sir.
Are we taking a performance hit by declaring that function every time increment's called?
I mean, sure, but
Assuming that incrementing the score is more difficult than it is here.
yeah, but you've got to balance always. Firstly, the performance hit is going to be very minor in this situation. But the reason, so firstly, we're doing this in a situation where we would never put one line of code inside a function. But typically, you may have 100 lines of code in this function. You want to sort of structure them in such a way that they're easy to read. Now, does that mean you're reassigning space and memory? Yeah. Does that make it more readable? Yeah. So it's always a trade-off on that.
Exactly.
It's perfectly fair to say, yes, we're saving additional space for this new function definition, but if you've got 100 lines of code in this function, there's always a trade-off on that basis. So it's perfectly fair to say, yes, we're saving additional space for this new function definition, but if you've got 100 lines of code in this function, now I can split it into a few sub-functions. Yes, I'm saving you space in memory, but it's far more readable.
And add1 is getting trashed every time.
And of course, add1 is absolutely being deleted once we leave this execution.
Unlike the very first example where we kept those functions around on every object.
Oh, yeah. Totally different than that. Absolutely deleted once we leave this execution.
Unlike the very first example where we kept those functions around on every object.
Oh, yeah.
Of course, exactly.
Totally different than that. Absolutely. All right, good question from Seth, sort of finessing around performance. We need to introduce arrow functions which bind this lexically. So lexical static scoping means where I was born, where I am saved, determines something about me when I get called. Well, what is the thing? Is what my this assignment is. Lexical static scoping means where I was saved. Lexical means the position on the page, so where I...
So this is the key solving scope with arrow functions. which is that. Okay, so solving scope with arrow functions. Okay.
I was positioned, where I was saved, determines something about me when I get called. Okay, all right, and that of course leads to the beautiful concept.
So for example, like this. Is there performance issue? Is there are performance issues with this approach? Yeah, it is. Because we are storing a function in our, except because we are storing as a function in our functionality. Okay. But the trade-off is that we can now have much more readability in terms of defining functionalities. Is there any performance issue? Or are there any performance issue with this approach? There's also a trade-off in that.
Of closure, most beautiful concept in JavaScript. My favorite. Where I was saved determines something about me when I get called. Okay, all right, and that of course leads to the beautiful concept of closure, most beautiful concept in JavaScript. My favorite concept. I was saved is what my this assignment is. Lexical static means where I was saved. Lexical means the position on the page. So where I was.
So the value of this using lexical, using arrow functions is exactly. So the value of this using arrow function is whatever if. So the value of this using arrow function is whatever was defined, aka is lexical,
Positioned, where I was saved, determines something about me when I get called. Okay, all right, and that of course leads to the beautiful concept of closure, the most beautiful concept in JavaScript. My favorite concept.
Yeah, because it allows you to store this data persistently. And
We are
also
writing-
bundle is a lot of functionality here.
Folk, our increment function, our login function, which we know our user wants. We are writing folk, our increment function, our log time. I'm going to talk through it. So positioned, where I was saved, determines something about me when I get called. Okay, all right, and that of course leads to the beautiful concept of on the page. So where I was positioned, where I was saved, determines something about me when I get called. Okay, all right, and that of course leads to the beautiful concept of closure, the most beautiful concept in JavaScript. My favorite concept. We are writing folk, our increment function, our login function, which we know our user one is going to have access to through the proto reference. We're declaring them separately from the function that, when called, gives us that object into user one that has access to those shared functions. So what? It doesn't matter, it's fine. But in other languages, you can do those first two parts, the function that they call it constructs the object,
Exactly.
the user creator function here, and the methods, the functions that will be
Exactly.
available on that constructor
On the
object, not
constructor
directly, but
object.
indirectly through the proto reference. You can do this assignment all bundled in one go. David, what's the construct that lets us bundle this assignment in one go?
Class.
It's called a class.
Called a
So
class.
now JavaScript says, oh, no. I want to mask even more. I feel so ashamed of my underlying prototypal nature. I'm going to mask.
I feel ashamed. Of my prototype object-oriented nature.
even more. And I'm going to allow you to rename what is clearly a function object combo with a prototype property a class. And I'm going to allow you to not even have to manually go user created dot prototype dot increment is a function, but instead just literally list off any functions, and JavaScript's going to take care of putting them into this prototype object.
Exactly.
I'm just going to say Oh, and by the way, I'm going to give this function, the one that constructs the object, I'm going to give it a subtitle. I don't know why, but I'm going to give it the subtitle constructor. I'm going to declare that bit first inside the class structure, and then I'm going to list off any functions, any and all functions that I want stuck in this object.
That I want to stuck in
I don't have to
there.
say, put them in the prototype. JavaScript's so ashamed of its prototypal nature that look, okay, we're writing our shared method separately from our object constructor itself, the one that creates the object, right?
So we're writing our share method separately from our object constructor itself, off in the user
We use the constructor,
prototype
we don't run this
object.
bit, we run the function bit.
Exactly.
Well, that constructs an object into user one. We're writing the constructor bit separately. Other languages let's do it all in one place. Year 2015, let's do it too. When you get to subclassing, I like this. Here,
Yeah.
I feel it's a little bit masking the truth. So let's see it side by side. Here it is. So there's our solution 3, which we're now quite familiar with. User creator function is declared. It automatically gets an object attached to it, which we have a prototype property on automatically. It's in there that we put any functions that we want the returned object from calling user creator to have access to. We'll call it again, user 20, it will have access to, and we put them in there using dot notation, stick them in that object. Solution 4 says, save yourself doing that. I'm going to do it for you.
I'm going to do
says
it for
JavaScript.
you. Exactly.
I'm going to grab any functions that you list inside of this new construct known as a class. Any functions you list, I'm going to grab them and I'm going to put them in there. But now you're not going to put them manually there yourself. I'll put them there for you. Huh. Why can we do it ourselves? Who knows? Who knows? Actually, once I get this talk there for you. Huh. Why can we do it ourselves? In there. But now you're not going to put them manually there yourself. I'll put them there for you. Huh. Why can we do it ourselves? Who knows? Who knows? Actually, once I gave this talk, someone was like, please stop criticizing classes. They're very important best practices. So we'll see classes make our lives much... Who knows? Who knows? Actually, once I gave this talk, someone was like, please stop criticizing classes. They're very important best practices.
Yeah, completely.
So, in there. But now you're not going to put them manually there yourself. I'll put them there for you. Huh. Why can we do it ourselves? Who knows? Who knows? Actually, once I gave this talk, someone was like, please stop criticizing classes. They're very important best practices. So we'll see classes make our lives much, much easier, especially in subclassing. Knows. Actually, once I gave this talk, someone was like, please stop criticizing classes. They're very important best practices.
Okay, so please stop criticizing classes.
So we'll see classes make our lives much, much easier, especially in subclassing. But it is a facade. It is a fake. If you know other languages that are actually classical, object-oriented in their nature, traditional object-oriented languages, they are not under the hood.
They are not under the hood.
Methods in a prototype
Calling
object.
in the
Believe
prototype.
me.
No.
But that's exactly what we're doing here.
Exactly.
So we rename the function bit of the function object combo, we rename it constructor. But that just means grab that bit and put it in the function bit of the function object combo. And then any functions which we were manually putting in the object bit of the function object combo in the prototype object, well, they're just listed off. Just one up. You don't even need to put the word function. I think we can technically put semicolons after them, and that works, but we don't put comma, we just list them off. And they'll all be grabbed one by one. As we go, when we declare the class, these bits are done immediately. They're not called, they're just saved immediately. We grab the first bit, just like we do over here, store it as a function. It immediately gets a prototype property on its object version, and then we grab these functions and we put them in that prototype object. I know I'm repeating myself here a bit, but it really is just so astonishingly identical. We just now rename the function object combo a class, and we wrap it as such. All right, folks, I'm not going to walk through this right-hand side here. We're going to see it much more in subclassing, so do not fear, we'll see it. Take a look at this. It's what's called syntactic sugar. That means nothing has changed under the hood. I will say this, when it comes to subclassing, classes implement some things under the hood quite differently. But there's nothing changed side by side. When I call user creator, now I call the function, just as I did before.
Because class is a different thing. Okay, so class is implemented, the mechanism of class is quite different of that. But after all, what they're doing is just under the hood, pretty much doing that.
Nothing's changed. Those increment login look like they're just sitting there. They're not just sitting there. They were grabbed and stuck in that prototype object. Line 1, declare class. Class. It comprises a function and object. Line 2, put the function bit, which note is exactly the same as the previous function, put it in and give it the subtitle constructor. When you call user creator, run this bit. It's the same. Grab increment, put it in the user creator dot prototype, put it in. Grab login, put it in user creator dot prototype, login. Everyone see, these are absolutely identical under the hood. Okay. I'm going to leave it at that for now, and then after the break, after lunch, we will build out a full class diagram out from scratch. But we'll do it in a more interesting setting of using that to generate, or to be the sort of to save us doing some work of creating what I think of as kind of subtypes of users. So we've got our users here. After lunch, we're going to see, well, hold on, what if I want to have users, user 1, user 20, user 3, but also paid users? Paid users are going to be a lot like regular users, but they're going to have some bonus properties and some bonus functionality that's only applicable to them. Well, when we build those users, paid users, we're going to probably want to use some of the previous work that we did to build users. And that is known as subclassing. And there, this new syntactic sugar of the class.
Exactly. Subclassing is the way of how you can now, based on previous work that you have done, how can you now extend that functionality?
Does make our lives much cleaner, but also masks even more of what's happening under the hood. But we are going to understand it all. We were talking about our solution 4 that was just a prettifying, a cleaning up of the sticking our function that creates our objects, and those objects need to combine all the data of user
all the
1,
data
user 20,
and the functionality
or 9 with all the functionality that can be applied to that user object. So we're not off on the hunt every time as we're writing our code to say, okay, we want to have the user score increase at this moment. Where's the increased score functionality, and can I even use it? No, don't worry. There it is. On the right-hand side, it's not on the object, though, because that would be a disaster. Copies on every single object, got 1,000 users, 1,000 copies of the increment function, complete memorially inefficient. No, complete inefficient in terms of memory.
Memory
and so
inefficient.
We put them all in one place, all those shared functions in one place, and then use this protobond, JavaScript's prototypal nature, to go and know that at the moment of the interpreter looks for a function, doesn't find it, doesn't give up, goes and looks up there. Now, we then made some refinements. That is, we said, let's not do the whole process of creating that object manually. Let's use
exactly. We pass through some of the process to don't create that object manually.
a keyword that's going to do all that inside.
It's going to use a new keyword that actually do that bound and create an object creation automatically for us.
Well, that also restricts a little bit where we've got to put the functions. So we put them there now. In that function that creates the object, dot prototype, which is an object, where we put the functions. Then
The
we
thing
said,
here,
man, rather than putting them in there manually, which to me does not feel that much work and actually feels kind of explicit and clear, well, you know, other languages kind of give us.
exactly, but to me is now we have this particular way of how can we be more explicit about, hey, this is the data, and this is the methods that we want to share across all of our data. Let's go to define that inside of the prototype. And yeah, this is actually somewhat great, but there's some other language that has quite there. Your father, your grandpa, has much more experience than you. Language like C and C++ and other language like Python is that they allow you to combine is the data and the functionality together. So you don't have to say, hey, this is a part of our data, this is when we define is our data, and this is when we define our functionalities, and then anytime we now create an object, we do that. No. JavaScript is so ashamed of this prototype object nature that they say they wanted to hide that. And with this class keyword, which is part of the specification of the object-oriented programming, they say it's gonna do that pretty much like where we do that in other language. Okay. For example, in Java, in C, C++, Python, it's like, hey, let's go to define is the data, okay, as well as their functionality, but in one bundle, in one code, all right?
Other languages let us combine methods with the function that creates the object that has access to those methods, all in one construct, known as a class. But they are not implementing it under the hood this same way.
Exactly.
So it's debatable whether it's a positive step to wrap all this up, because while JavaScript fundamentally is not a traditionally object-oriented language, it is a prototypal language, because it's faking it. It's under the hood, it's doing this stuff, and I promise you, if any of you use Java or C++, any of these languages, their implementation of classes in object-oriented design is not this under the hood. It's something quite different. Who knows what? I don't know. But I know it's different. So it may be debatable. That's why we're building up a true understanding of how. Otherwise, we just go straight to this. We just go straight. If you were in another language, you go straight to solution 4, because there is nothing under the hood on that. It is what it is. But here, solution 4 is a mask for a bunch of shit under the hood that we need to understand to properly use solution 4. Okay. There we go. So solution 4 merges a new standard, feels more like the standard or the style of other languages,
like Python, exactly.
But nobody knows how it's working under the hood. If solution 3, folk didn't know, but at least they saw the prototype word. Now, nobody knows, but we do.
Right.
So you will not be one of those folk, you will be the special ones who know. Now, that proto-reference, that little proto-property, sorry, that refers to other objects, JavaScript decides that allows us to give an object like user1 or user20 bonus functionality that's not on the object itself. Well, it's like the increment function. It's not on the object itself, it's bonus. Well, actually, in JavaScript, all objects, and by the way, functions, remember, are also objects, so all objects and functions, and by the way, arrays are definitely just objects with property 0, 1, 2, 3. Those are the keys that allow us to go and access things in arrays as though they are arrays. They're not actually under the hood sort of lists in the conventional sense of the language, they're just objects. They all actually get a bunch of bonus functionality by default. That is to say, all objects have a hidden underscore proto underscore property that links off to a store of functions. Let's see this play out. I'm just going to give you a little preview. See that has own property? I'm not sure that's on obj. So where the hell is it coming from? Now you may just think, well, I don't know, JavaScript. Well, actually, it's pretty explicit, and it's going to follow this proto path. All right.
So I just want to now
We are right.
exactly. So I just wanted to wrap this up here by saying this was defined lexical. So now that we solved is the problem here, okay?
Folk, our increment function, our login function, which we know our user1 is going to have access to through the proto reference, we're declaring them separately from the function that when called, two parts. David, what's the construct that lets us bundle this assignment in one go? It's called a class. So now JavaScript says, oh, no, I want to mask.
It's a ES6 class keyword. ES6 class keyword. Okay. The hell is this? What? There you go. ES6 class keyword. So it's a. So now that we know how to so now that we know how to let the language automatically create objects and bind functionalities in a bind functionality and bind share functionalities, which is something important here. So now that we know how the language automatically create objects and bind shares functionality in a memory efficient way, because that's what it is, you know. So now that we know how to let the language automatically create create objects, okay, and bind share functionality in a memory efficient way, like this, okay. So like this, okay. All right. So for example, like this. Exactly like this. All right. So the bind share functionality in a memory efficient way. So first, we define our data segment in a function object constructor. They have all of this series of step model. Okay, first we define our data segment in the functions object constructor, in our case called user creator. In our case, user creator. All right. And then define its methods. And then define its share methods Yeah, and then define it is share methods. And then define it is share methods that will be bound in a memory efficient way with our data thanks to the new keyword. And that's something interesting and important to get it. Okay? Okay. Holy moly. JavaScript designers are ashamed of the prototype object-oriented nature. JavaScript designers are ashamed of the prototype object-oriented nature, so they now nature, and also if we take a look at other languages like C, C++, or Python, when you can define in one construct, powerful concept here, in one construct, data and methods, okay? When you can define in one construct data and methods, that's why we have class keyword. That's why we have class keyword, or this syntactically sugar, or syntactic sugar of object definition and creation. Okay, of object definition. The mechanism is quite different, but in the end, we want is to bundle together data and functionality and methods. Makes a lot of sense. God damn it.
Sir, run this bit. It's the same. Grab increment, put it in the user creator dot prototype, put it in. Grab login, put it in user creator dot prototype, login. Everyone see these are absolutely identical under the hood. Okay. I'm gonna leave it at that for now, and then after the break, after lunch, we will build out a full class diagram out from scratch. But we'll do it in a more interesting setting of using that to generate, or to be the sort of to save us doing some work of creating what I think of as kind of subtypes of users. So we've got our users here. After lunch, we're going to see, well, hold on, what if I want to have users, user 1, user 20, user 3, but also paid users? Paid users are going to be a lot like regular users. But they're going to have some bonus properties and some bonus functionality that's only applicable to them. Well, when we build those users, paid users, we're going to probably want to use some of the previous work that we did to build users. And that is known as subclassing. And there, this new syntactic sugar of the class does make our lives much cleaner, but also masks even more of what's happening under the hood. And they're not just sitting there, they were grabbed and stuck in that prototype object. When I call user creator, now I call the function, just as I did before.
Nope.
We were talking about our solution 4 that was just a prettifying, a cleaning up of the sticking our function that creates our objects, and those objects need to combine all the data of user 1 or user 20, that is name, either, score 9, with all the functionality that's going to be applied to that user object. So we're not off on the hunt every time as we're writing our code to say, okay, we want to have the user score increase at this moment. Where's the increased score functionality, and can I even use it? No, don't worry. There it is. On the right-hand side, it's not on the object, though, because that would be a disaster. Copies on every single object, got 1,000 users, 1,000 copies of the increment function, complete memorially inefficient. No, complete inefficient in terms of memory. And so we put them all in one place, all those shared functions in one place, and then use this proto-bond, JavaScript's prototypal nature, to go and know that at the moment to combine all the data. We were talking about our solution 4 that was just a prettifying, a cleaning up of the sticking our function that creates our objects, and those objects need to combine all the data of user 1 or user 20, that is name, Eva, score 9, with all the functionality that's going to be applied to that user object. So we're not off on the hunt every time as we're writing our code to say, okay, we want to have the user score increase at this moment. Where's the increased score functionality, and can I even use it? No, don't worry. There it is. On the right-hand side, it's not on the object, though, because that would be a disaster. Copies on every single object, got 1,000 users, 1,000 copies of the increment function, complete memory
inefficient.
No, complete inefficient in terms of memory. And so we put them all in one place, all those shared functions in one place, and then use this proto-bond, JavaScript's prototypal nature, to go and know that at the moment of the interpreter looks for a function, doesn't find it, doesn't give up, goes and looks up there. Now, we then made some
The interpreter loops in for to find it.
That is, we said, let's not do the whole process of creating that object manually. Let's use a new keyword that's going to do all that inside automatically for us. Well, that also restricts a little bit where we've got to put the functions. So we put them in there now, in that function that creates the object, dot prototype, which is an object, where we put the functions. Then we said, man, rather than putting them in there manually, which to me does not feel that much work and actually feels kind of explicit and clear, well, you know, other languages kind of other languages let us combine methods with the function that creates the object that has access to those methods, all in one construct, known as a class. But they are not implementing it under the hood this same way. So it's debatable whether it's a positive step to wrap all this up, because while JavaScript fundamentally is not a traditionally object-oriented language, it is a prototypal language, because it's faking it. It's under the hood, it's doing this stuff. And I promise you, if any of you use Java or C++, any of these languages, their implementation of classes in object-oriented design is not this under the hood. It's something quite different. Who knows what? I don't know. But I know it's different. So it is maybe debatable. That's why we're building up a true understanding of how, otherwise we just go straight to this. We just go straight, if you were in another language, you go straight to solution 4. Because there is nothing under the hood on that. It is what it is. But here, solution 4 is a mask for a bunch of shit under the hood that we need to understand to properly use solution 4. Okay, there we go. So solution 4 merges a new standard, feels more like the standard or the style of other languages like Python, Java, but
So this is now recap of the class keyword. So recap of the class keyword as it is.
nobody knows how it's working under the hood. Standard. There we go. So solution 4 merges a new standard. There we go. So solution 4 merges a new standard for a bunch of shit under the hood that we need to understand to properly use solution 4. Nobody knows how it's working under the hood. If solution 3 folk didn't know, but at least they saw the prototype word, now nobody knows, but we do. All right. So you will not be one of those folk, you will be the special ones who know. Now, that working under the hood. If solution 3 folk didn't know, but at least they saw the prototype word, now nothing under the hood on that. It is what it is. But here, solution 4 is a mask for a bunch of shit under the hood that we need to understand to properly use solution 4. Okay, there we go. So solution 4 merges a new standard, feels more like the standard or the style of other languages like Python, Java, but nobody knows how it's working under the hood. If solution 3 folk didn't know, but at least they saw the prototype word, now nobody knows, but we do. All right. So you will not be one of those folk, you will be the special ones who know. Now, that proto reference, that little proto property, sorry, that refers to other objects, JavaScript decides that allows us to give an object like user1 or user20 bonus functionality that's not on the object itself. Well, it's like the increment function. It's not on the object itself, it's bonus. Well, actually, in JavaScript, all objects, and by the way, functions, remember, are also objects, so all objects and functions, and by the way, arrays are definitely just objects with property 0, 1, 2, 3. Those are the keys that allow us to go and access things in arrays as though they are arrays. They're not actually under the hood sort of lists in the conventional sense of the language, they're just objects. They all actually get a bunch of bonus functionality by default. That is to say, they all objects, have a hidden underscore proto underscore property that links off to a store of functions. Let's see this play out. I'm just going to give you a little preview. See that has own property? I'm not sure that's on obj. So where the hell is it coming from? Now you may just think, well, I don't know. Bonus. One of those folk, you will be the special ones who know. Now, that proto.
So, but now we know what to do, what it does.
Reference. That little proto property, sorry, that refers to other objects. JavaScript decides
Uses proto link to give objects, functions, and array a bunch of bonus features. All objects by default have protos. Exactly.
that allows us to give an object like user1 or user20 bonus functionality that's not on the object itself. Well, it's like the increment function. It's not on the object itself, it's bonus. Well, actually, in JavaScript, all objects, and by the way, functions, remember, are also objects, so all objects and functions, and by the way, arrays are definitely just objects with property 0, 1, 2, 3. Those are the keys that allow us to go and access things in arrays as though they are arrays.
Because object create what it does is override that.
Conventional sense of the language are just objects.
But all
They all
object
actually get a bunch of
has
bonus functionality by
a
default.
bunch of.
That is
So all objects in JavaScript, they get a bunch of specific functionalities by default.
Say they all objects have a hidden underscore proto underscore property that links off to a store of functions. Let's see this play out. I'm just going to give you a little preview. See that has own property. I'm not sure that's on obj. So where the hell is it coming from? Now you may just think, well, I don't know, JavaScript. Well, actually, it's pretty explicit and it's going to follow this proto path. All right.
So also one of the reasons why we're gonna.
It feels more like the standard or the style of other languages.
So the default prototype change. Exactly, because the whole point of looking now at the introduction of oriented programming, and then also see how can we now create objects, object literal, dot notation, the using object.create as a way to have much more control about what this object can have access to, and also how can we create objects with functions. How messy and memory inefficient it is, because anytime we create a new object, the data is unique, which is great, so we store that in memory, but the functionality remains the same. And we also are creating multiple copies all of that. So would it be nice to have a particular place where we can have all of those methods and functionalities in one place, and anytime we create an object with this unique data, we make a bound to that. And if we want to apply any of those methods, we can do that to the proper and relevant data. That's what the prototype chains allow us. And the way to do that is before using object.create for that. And that was quite lengthy, quite also handcrafted and tedious. It becomes very, very repetitive. So the JavaScript designers say, you know what? That's going to make our life a little bit much more easy by allowing you, from the JavaScript perspective, just JavaScript is now giving you the ability to automate the process of creating and creating an object and share common functionality while being memory efficient with the new keyword. And we need to understand what this new keyword is doing behind the scenes. So again, now we need to first take a look at how can we write our objects using this new keyword, where first we define is all of our data in a function, okay? And then our functionality is under this hidden property called prototype. That's great, that's cool, especially when we want to define now more functionality inside of those methods that are gonna live inside of a prototype. The value of this, which is the way how you can reference to the data, because the dynamic nature of JavaScript, the values is going to refer to whatever is on the left side if we're not careful with that, by default, uh, if the value of JavaScript, or if the value of this, which is making the reference to the data, which by default is whatever is on the left side, when you run that function, now if we don't know what is, or if the value of this is empty, is undefined, it will point that to the window objects, which makes the language weird in terms of behavior. So it doesn't give us predictability. That's why we have things like bind or apply, or trying to store is the value of this, the relevant value of this that points to our data, okay, into that variable, and then apply the methods to our data. It becomes quite a standard. So with that, now that we look at this particular way of how can we define our data and the functionality, and when we need to call that, we use a new keyword. So JavaScript designers take a look at another language like Python, C++, and C# and say, hey, in those languages, there is a construct that bundles all of the data and functionality in one place. They call that class. So because JavaScript is so ashamed of this prototype object-oriented nature, so they want to mask it. They want to show is this facade here with the class syntax, okay? Where it allows you to encapsulate or to define in one place is your data using the constructor, which is, after all, that's exactly what you're doing here with the new keyword, and the increment and the login, which will say, hey, let me put it all of these methods under the prototype, under the prototype property function constructor. So that's great, because now the language looks like much more like any other languages. But the mechanism here of using class is something that we're going to see in a much more deeper, especially when you want to share when you want to share functionalities, or when you want to, for example, reuse some of your functionality and extend that. We're going to see what it's doing behind the scenes, but essentially it's doing is this. So class in these solutions with the new keyword is essentially doing that. Again, because now the language itself uses the prototype object as a way to share data, as a way to share functionality in a memory efficient way, which is kind of weird of how other language like Java and C++ works, which I don't know how they work, but they definitely are not using POOP. So the benefit of this approach is that it looks like more like other languages, like Python. Great, cool. But it comes with a trade-off, because a lot of developers doesn't know how the things work behind the thing, and they fail at interviews, because at the end of the day, this is something important. This is how we actually build applications at scale in a professional engineering environment. And then a word of how now the prototype by default works, because at the end of the day, it has all objects in JavaScript. The proto has a reference to the object from where the function object constructor prototype, where from there is where they're going to inherit all of the property and method relevance to that. That's one. And also you can extend is, or you can reuse some of their functionalities from those objects, and you can extend that with your own. And that's exactly what we're gonna do, and we're gonna see in the next videos. So with that, take care. Bye bye. Jesus Christ.